Okay, this video is about section 9-2 in your textbook, and this deals with ideal stoichiometric calculations. Um, Again, as I've said, your textbook treats each of the four different types of stoichiometry calculations as a different type of problem, and they want you to recognize what type of reaction you have, whether it's mole-mole, mole-mass, mass-mole, or mass-mass, and then solve accordingly. And as I said, we're going to use a chart that will take care of all of that for you. So you don't really need to worry about those, and you won't need to write out calculations or mole ratios, because your table will take care of everything for you. So all you'll have to do is some arithmetic. You will need your calculator, but if you work carefully, it's actually fairly easy. The first thing you need to do in doing a stoichiometry problem is to make sure that you have a correctly balanced equation. And of course, your equation is not correctly balanced until you have the correct formulas for each of the products and reactants. And so you've got to be able to write the correct products and reactants, especially when you're given a word equation. And then you have to be able to balance that equation. It's always a good idea to check, even when you suspect that the equation is balanced, just check it to make sure that it is balanced before you get started. Okay, let's take a look at our first problem here. We're given hydrogen and oxygen can react to form water. How many moles of hydrogen are required to produce 5.0 moles of water? Alright, the first thing we need for any one of these problems is a balanced chemical equation. We're not given that here, so we're going to have to come up with it. So we'll start out by writing H2, hydrogen, plus O2, oxygen, yields H2O, water. Alright, now we have to balance it. We have 2 hydrogen on the left, we have 2 hydrogen on the right. We have 2 oxygen on the left, we have 1 oxygen on the right. So we have to change that to a 2, but now we've changed our hydrogen here. We have 4 hydrogen there, so let's make this 4 hydrogen over here. We now have 4 hydrogen on the left, 4 hydrogen on the right, 2 oxygen on the left, and 2 oxygen on the right. That equation is balanced. We can now put that down into the chart. This is the chart I was telling you that I was going to give you, and you've actually seen this before. We have mass, formula mass, and moles, and we've just added one line here. That line is this ratio line, and then I've added columns here too, because each component, each element of your equation is going to take up one column. And so I'm going to rewrite my equation right here. 2H2 plus O2 yields 2H2O. Now, the first thing that we're going to do is to use the ratio key, or row, and I'm going to put these numbers, the coefficients of each of these numbers, down in the ratio column. So this 2 comes down here. I write a 2. It's understood that there's a 1 there and a 2 here. Now we're actually ready to start solving our problem. We were asked how many moles of hydrogen are required. Okay, it's asking us to solve this. I like to put a little asterisk there, just so I know exactly where is it that I'm trying to get to. And then how many moles of hydrogen are required to produce 5.0 moles of water? Well, if we want 5.0 moles of water here, how many do we need there? Well, remember our rule is divide down. So I take my 5, I'm going down, so I'm going to take 5, let me show you that. We're going down here, so we'll take 5 divided by 2 is 2.5, and we can do this in our head. You could use your calculator if you want to. And now we're going to come over here and we're going to go up. So now we're going to multiply. So 2.5 times 2 is 5.0 moles. So we're done. We've solved that problem. Our answer here is 5.0 moles H2. All right, and it's really that easy to do these problems. Now, some of them get a little bit more involved. You're going to have to calculate formula masses, and you will need your calculator to do many of these calculations. But this is a very simple problem. You can see from this now that this is a mole-mole problem. We started with 5 moles of water, and we found that it would take 5 moles of hydrogen in order to get the 5 moles of water. So that's the use of the table. Very simple example, and probably the easiest type of problem, the mole-mole type of problem. All right, let's take a look at another example. Here's our problem. Lithium hydroxide is used in spacecraft to absorb the carbon dioxide breathed out by an astronaut. How many grams of lithium hydroxide is needed to absorb the 21 moles of carbon dioxide breathed out by an astronaut in a day? Okay, now if you read that carefully, you see we're being asked to find the number of grams of lithium hydroxide that's needed to absorb a number of moles of one of the reactants. And so this is what's known as a mole mass problem, but it really doesn't make any difference to us. Let's first of all take a look at the equation for this. We need the balanced equation, and so we have lithium hydroxide plus carbon dioxide yields lithium carbonate plus water. Now, this was not one of the 5 types of reactions that we learned about. This one was a little bit different. I would not expect you to be able to come up with this reaction on your own. But so here I have given that to you, but it's not balanced. Let's balance it. We have 1 lithium on the left. We have 2 lithiums on the right. So let's make this 2. Now we have 2 oxygen here in the lithium hydroxide and 2 here, a total of 4 on this side. We have 3 in the carbonate and 1 in the water, total of 4 on that side, so the oxygen is balanced. We have 2 hydrogens here. We have 2 hydrogens in the water, and we have 1 carbon and 1 carbon. That is now a completely balanced chemical equation. So we can write that here in our chart. And immediately I'm going to put my ratios down here. Okay, and that's just the coefficients. Bring those down. And now let's take a look. We want to know how many grams of lithium hydroxide. So this is where we need to get to. We need to solve for that. And we're starting out with the 21 moles of carbon dioxide. Now, you can see here that we're going to have to start at the 21 moles. We're going to start here. We're going to go down this way, and then we're going to come up here. All right, and you can also see that we're going past the formula mass here for lithium hydroxide. So we're going to need to calculate that. We need to calculate the formula mass for lithium hydroxide. So let's do that. Lithium. And let's see, the formula mass for lithium is 6.941. And the others, the oxygen we know, 15.9994, and the hydrogen is 1.00794. So, lining up our decimal points, we get 6.941, 15.9994, and 1.00794. Okay, and so when we add these together, we end up with 23.94334, which we now have to look at rounding. In this situation, we can just look at which number has the least number of decimal places. Okay, our rule for addition and subtraction is that we round to the column of the leftmost last significant figure, and that's this 1 right here, or to the third decimal place. So we're going to round to the first of the 3's there. We're going to report this number then here as 23.943, and that's grams per mole. Okay, so now we're ready to do our calculations, and you can do this on your calculator. We're going to start out going down, so 21 divided by 1 is 21, times 2 gives us 42. Now, I leave this optional up to you. I don't like to write the number in here. Now, if you really wanted to, you could. The reason I don't want to do that is because there are many times when you're going to be doing multiple calculations here, and I want you to avoid the temptation to use that number in further calculations. So we've got 42 times 23.943, and when we multiply that out using to 2 sig figs, that comes out as 1.0 times, I think it comes out to 1,003 point something, which to 2 significant figures, it's 1.0 times 10 to the third grams. And so our answer is 1.0 times 10 to the third grams LiOH. Now it's important that you express your answer like this. 1.0 times 10 to the third grams doesn't tell me grams of what. So you need to tell giving your answer grams of lithium hydroxide, or whatever the compound is. One other thing I'm going to state here, when you are doing these problems like this, one of the most common mistakes that students make is when they're calculating the formula mass, they want to use the 2 here. They want to use this 2. Don't do that, all right? That 2 you have taken care of down here. So if you also include it in here, you're introducing that into the problem 2 different places. Don't do it. The mass for lithium hydroxide has to be 23.943 grams per mole, whether you have a 1, a 2, a 3, a 4, a 5, whatever the coefficient is there, doesn't make any difference. Lithium hydroxide is still LiOH. This number is just particular to this particular problem. So don't introduce that 2 when you're calculating the formula mass, okay? Formula mass, you've done that many times before, and so just continue to calculate your formula mass as you have done in the past. Okay, let's take a look at a third problem, and we have that here. Iron forms rust according to the equation 4Fe plus 3O2 yields 2Fe2O3, and of course you know that is a composition reaction, or a synthesis reaction. And so we have our chart here, and we've got the balanced equation, so there's nothing for us to do with that, so we can transfer that directly down here into our chart. Okay, and again, I'll immediately put my coefficients down here to take care of those. We are being asked how much iron is needed to form 100.0 grams of rust. So we're going to start here with this 100.0 grams of rust, and we have to go up here to the Fe. Now, we will need to calculate, since we're going to go from, and let me just kind of draw this line in again. We're starting here. We're going to go down this column, and then we're going to go up that column. And remember, our rule is divide down, multiply up. In this situation, we're going to need the formula mass for the iron oxide, the Fe2O3, and for the iron. So let's go ahead and calculate that. We have our iron, and I'm using this formula here. Remember, ignore the coefficient now. We're just using the subscripts. There are 2 irons in that, and the formula mass for iron is 55.845, and then we have our oxygen. There's 3 of those times 15.9994. This one gives us, when we multiply that, that's 111.690. Now this is something to be a little bit careful of. When you're multiplying here, notice when this ends in a 5, we're multiplying by 2, so your calculator will give you 111.69. It's going to drop off that last 0. You have to recognize that that is a significant figure and include it in there. And then our 3 times the 15.9994 is 47.9982. We add those 2 together. And we got 159.6882. We have to round to the 3rd decimal place because we have 3 decimal places here. More than that here. And we round to the column of the leftmost last significant figure. So we're going to report this as 159.688, and that's grams per mole. The iron is an easy one because since that's elemental, that's just the 55.845 that we looked up back here. Now we're ready to do our calculations. So again, get on your calculator. Take 100. You can put in the 0.0 if you want to, although that's not going to really do you any good. Just extra keystrokes. 100 times, or I'm sorry, divided by 159.688 divided by 2 times 4 times 55.845, and I get 69.94 grams, and that is my answer. So we'll write that down here, 69.94, and I used 4 significant figures there because that's what I had in the 100.0. And again, remember, tell me grams of what? Grams of Fe. There's our answer. And that should give you a good sampling of stoichiometry problems. Just remember to follow those instructions. I suggest that you look back on these as you need to find little tips and so on, and have fun doing them. Thank you.